Hello, this is Riley Benavides, and I'm showing you my 8-bit and adder and my 8-bit subtractor. This is for my CECS 225 Lab Section 2 for Susan Nachawati. Right here, I have my code for my 8-bit adder. I'm introducing inputs carry in, A, B, my output, and my carry out. And then for my 8-bit adder, we are going to reference our ripple carry, and we're going to have 2 ripple carries in this 8-bit adder. And as we've seen in our other labs, these ripple carries do include our full adders. They include 4 full adders. I will show you when I show you the schematic. And then those full adders include half adders, 2 half adders, and yeah. So I'm first going to make this one our top, and then I'm going to run the synthesis. While that is running, I guess I can put that in the background. I guess I can show you my 8-bit subtractor. In my 8-bit subtractor, I have carry in, but we called it B in. You're introducing A and B, and you have an output, which is going to be the difference of the two because we're subtracting. And then output, B out, carry out. And we are wiring E. It's going to be our A because A is going to extend to all of the XORs. So this is our first XOR, and we are going to have 8 of them. And then from those XORs, we have one output, and we are going to use that output in our adder 8. And right here, we use adder 8 to get one 8-bit adder for the end of our subtractor. Just a couple more seconds. It should be loading pretty soon. My computer's a little slow, so. The fan is working super hard. Alright, here's the schematic. Excuse me. That is for the subtractor. Alright, this is going to be our 8-bit adder. As you can see, we have 2 ripple carries, and inside each ripple carry we have 4 full adders. Excuse me, let me zoom out real quick. We're gonna have 4 full adders in 1 ripple carry. And then in those full adders, we have 2 half adders. And that is what the half adder looks like. And that is what our, not simplified, the other one, if you were to extend all of the boxes out. This is what it would look like for your 8-bit adder. Give my computer one more second. Yes, that is our 8-bit adder right there. As you can see, it has A, B, and carry in. And then this carry out goes to this ripple carry as its carry in. And then its output is right there, and this output is right here, and has a carry out right there. Alright, and then I'm going to set subtractor as the top so I can show you what the device looks like. Alright, and then here is what our 8-bit subtractor looks like. As you can see, we have 8 different XORs for the inputs. This is A, extends to all of them. So does B. And then A also goes straight through to this adder. And this adder will have a carry out and a difference because it is a subtraction. Alright, and then we have our test bench right here. And I'm going to run that simulation for you. I could tell a joke while it's loading. Why was the stadium hot after the game? It's because all the fans left. Haha. Extra credit opportunity right there. Alright, it's loading. Alright, and then my timing diagram is going to end up looking a little bit like, give me one more second, go to the beginning. This is the timing diagram right here. These are the different values that it's inputting and all that. So let's take a look at our output. Alright, this is the output in binary and then the output in decimal. As you can see, our adder right here, 154 plus 146, goes over the 8-bit. So we're going to have like an output of 44 with a carry. The subtractor test is 175 minus 64, which is 111. And then 1 borrow, 107 minus 4 is 103. 43 minus 49. It's not 250, but that is a negative. So it is yeah, it's really you know, it's a negative number, so it's gonna be a little bit irrational. But yeah, so we can see that it all checks out, it all works. Yeah, have a good night.